All right, guys. So, I'm going to record 31B, which is just combustion reactions. So here we go. Let's do that. So combustion reactions are just a little bit, sometimes more complicated than the ones we did in our previous notes, which is balancing the other types of reactions. The reason why is sometimes the numbers get way bigger. That's really it. It's not that it's necessarily that much harder. Sometimes the numbers get way bigger. Might take you a little longer to balance them sometimes. So we put them in their own little section to practice again. Now some hints. A lot of times what I'm going to balance first that will help myself out is I'm going to balance carbon, then hydrogen, then I'm going to balance my oxygen last. That usually helps yourself not make too many mistakes and not have to go back and fix things over and over. If you start with carbon, then go to hydrogen, then go to oxygen when we're dealing with combustions. And that's all that's in a combustion reaction is carbons, hydrogens, and oxygens. So that's kind of the order you want to go in. All right, so like we did the last time, draw the line down the arrow. I'm going to write down what's in this equation. So we have carbon, hydrogen, and oxygens. That's what is in a combustion reaction. And same thing on this side. Carbon, hydrogen, and oxygen, keeping them the same order just to help my eyes see back and forth when they're balanced. Write down how many I have to start. So on this side I have 4. On this side I have 8 hydrogens. On this side I have 2 oxygens. On this side I have 1 carbon. On this side I have 2 hydrogens. And here's where the little tricky part that hasn't happened to us yet. There's an oxygen here and here on this side of the arrow. I have to add them together and to keep track of both of them. That's where it gets a little more tricky for you to remember. So I have 2 oxygens here and I have 1 oxygen here. So I have 3. Okay, so I have 3 oxygens. Now, normally, in my other types of reactions, I would tell you to go with the odd even problem, not in a combustion. In a combustion, it's easier to start with carbon and then hydrogen and then oxygen. I'm going to do that. All right, so my carbon over here is a 4, so I want to make my carbon over here a 4. Well, what can I put in front of that carbon? What can I put in front of CO2? That'll give me 4 carbons. So it has a 1, so something times 1 would be 4. 4 times 1 is 4. Okay, but that also changed my oxygen. So 4 times 2 is 8. But remember, it still has this little weird one over here. So now it has 8, 9. So even the numbers are already getting a little big. A lot of times the oxygens can become kind of large numbers. Okay, so now I'm going to try to balance my hydrogen. So on this side I have 8. On this side I only have 2. So what can I put in front of this hydrogen that'll make me have 8? So what times 2 is 8? Well, again, it's 4. So 4 times 2 is 8. So I fixed my hydrogen, but it also changed my oxygen. So I have 4 times a 1, so that's 4. So I have 4 oxygens over here. I still have the 8 oxygens over there. So 4 plus 8 is 12. Okay. Lastly, I'm just going to see if I can make this side match. As long as this is an even number, you can make it match. If it's not, if it's an odd number, then you're going to have to put something in front of this one to change the whole thing. But we'll get to one of those in a second. So this is an even number. So what times 2 is 12? 6. And now when putting that 6 there, I now have 12 oxygen. So I have 4, 4, 8, 8, 12, 12. It's balanced. I'm done. Yay. And over here, they're all combustion reactions. So kind of silly, just you could still be writing the types, but oh well, if that's what type it is. If the question asks you for what coefficients you use, or that's the number you had to write in front, so I'd say I used a 1, because I don't have to write the 1, but there is a 1 there. And then 6, and then I put a 4, and then I put another 4. And that's what made it balanced. Okay, let's do the other one. So same process, draw a line down the middle, but in this case, this is a combustion, so it's just a CH and O. Let me write that H. CH, oh my gosh. And so it's just like certain parts of my board just are way worse than other parts. I can't seem to make that look like an H. Or that one. Awesome. Okay, that's closer. I'm sorry, those are H's. All right, so carbon is a 2. Over here, carbon is a 1. Over here, hydrogen is a 6. Over here, hydrogen is a 2. Over here, oxygen is a 2. It's always going to be that, but it's always with oxygen gas, so it's 2. And then over here, remember it's going to have those 3 because there's a CO2 and an H2O, so there's always going to be, you have to think about those both oxygens. So over here I have 2, and over here I have 3. So pretty much always, just like last time, we started with an odd even problem, but I'm going to ignore that, and I'm always going to start with carbon first. So carbon over here is 2, carbon over here is 1. So I'm going to try to make this become a 2. So what number can I put in front of that carbon that multiplies with a 1 that gives me 2? So 2 times 1 is 2. Now that also changes my oxygen. So it changes my oxygen to a 2 times 2, which is 4. But I also have this oxygen over here. So 4 plus the 1 I already have. So now I have 5. Okay? We fixed our carbon. Let's move into hydrogen. Hydrogen over here is 6. And hydrogen over here has 2. What times 2 is 6? Put a 3 in front of it. So 3 times 2 is 6. Right, there we go. That also changes my oxygen. So I have a 3 times 1. That's 3. Plus the 4 I already had. So 3 plus the 4 I already had is 7. Okay, so here's where that problem came in. I have an odd number of oxygens over here. There's nothing I can put in front of that oxygen that's going to multiply to give me a 7. Nothing. Nothing times 2 is 7. It's an odd number. It can't work. So I know that this oxygen can't end up being a 7. So I know that basically everything I just did is going to have to change. Okay? So when you come into this problem, you're going to start by adding numbers in front of this one, the first compound. This is your hydrocarbon. And generally just start with 2. A lot of times it's all you need to do. Start with 2. Sometimes you have to go up. So let's start with 2. That changes my carbon to a 4 over here and changes my hydrogen to a 12. Okay? So just like last time, I'm just going to start over, make my carbons and my hydrogens match, and see if I can fix my oxygen again. So now my carbon is a 4. I'm going to make this carbon a 4. Okay, well, sometimes erasing is needed. Sometimes you got to redo it, especially in combustions. So what can I put in front of this carbon now times 1 to give me 4? Will be 4. So if I put a 4 in front of it, then that carbon is 4. But it also goes to that oxygen. So 4 times 2 is 8, plus the 3 that I already had. So 8 plus 3 is 11. Okay, so now we have 11 over here. All right, now let's see if I can fix my hydrogen. So my hydrogen over here is a 12 now, so 6 over here. Okay, so now that 3 is not going to work. So what can I multiply by 2 that gives me a 12? Well, 6. So 6 times 2 is 12. And that changes my oxygen. So that's 6 times the 1, which is 6, plus the 8 I already had. So I have 4 times 2 is 8, plus the 6, so 8 plus 6 is 14. Okay, well now I fix it. Now I have an even number of oxygens, and I know that something times 2 is going to give me that even number. So what times 2 is 14? 7. And now we're balanced. So we got 4, 4, 12, 12, 14, 14. Okay. So again, combustion is my type, but I'm just going to write the coefficients I use. So we had to use a 2, we had to use a 7, we had to use a 4, and we had to use a 6. And that's how it ended up getting balanced. Okay, the last one, I want to scroll up because I feel like it's going to write even worse if I don't scroll down. Okay, clear. All right, last one. So make my line down the center. I'll do C, H, and O, C, H, and O. I have 5 C's, I have 1 C. I have 10 H's, I have 2 H's. I have 2 oxygens, and I have that group, so I have 3. All right, starting with carbon, what can I do to make it 5? 5. So 5 times 1 is 5, but that also changes my hydrogens. So the 5 times 2 is 10. 10 plus the 1 I already have is 11. All right. Now I go back to my hydrogen. So my hydrogen over here is 10. My hydrogen over here is 2. What times 2 is 10? 5. Put 5, so 5 times 2 is 10. But that also changes my oxygen. So 5 times 1 is 5. Plus the 10 I already had is 15. Okay, done. We're in that same problem we were last time. I ended up with an odd number. I know that's not going to work. So I'm going to go ahead and put a 2 in front of my starting compound and restart. So I have 2 times 5, which is 10 carbons now, and 2 times 10, which is 20 hydrogens now. So getting to be bigger numbers, that's fine. It's just what happens sometimes. All right, so now how can I make this side match? So what can I put in in front of that carbon to make it have 10. Well, 10. I have to put a whole 10 there. And that makes it have 10 carbons. So that also goes my oxygen. So 10 times 2 is 20. So now I have 20 oxygens plus the 5 I already had. So now I have 25 oxygens. Okay, so then I fix my hydrogen. So hydrogen has 20 over here now. Hydrogen over here, what can I put in front of that to equal 20? So 10, again, 10 times 2 is 20. That also affects my oxygen though. So 10 times 1 is 10. And then the 20 I already had, so I had 20. Now I have 10 more. So now I have 30 oxygens over here. But it's an even number, so it's fine. I know I can get anything to equal that even number. Something times 2 is 30. So what times 2 is 30? 15. Okay, so I put that 15 there. It changes to 30. And now I have, it does not look like a 30. So I have 10, 10, 20, 20, 30, 30, and there you go. We're done. So this combustion reaction had a 2, a 15, a 10, and a 10. So that was like the biggest number you've seen. Most of our other reactions will balance with much smaller numbers. Combustions, however, can get bigger, okay? So you're seeing that process of how to balance a combustion reaction. And we're done with our balancing notes now. Okay, and